In 2024, China has surpassed Japan and Germany to become the world's largest car exporter, with over 5.7 million vehicles exported in that year. This achievement is quite remarkable because, in comparison to many of the goods that China exported in the previous decades that were cheap and of low quality, Chinese EVs are actually very well built and are very competitive in the global market. In many areas, Chinese EVs are actually superior than their European, American, Japanese, and Korean automakers. EVs from Chinese brands like Xiaomi and XPeng have superior battery performance, enhanced comfort, and superior software. But most importantly, Chinese EVs are markedly cheaper. Just how cheap, you may ask? A journalist from NPR noted that BYD's Seagull, an entry-level car, could double the price and pay the 27.5% tariff, and it would still undercut every EV for sale in the United States. And as a result, the Chinese EVs are selling like hotcakes in emerging economies like Brazil. All this leads us to asking the main question: what are the factors that has led to the rapid rise of China's EV sector? The theory underpinning the rise of China's EV sector can be traced back to Adam Smith's seminal work, The Wealth of Nations, in which he discussed the concept of division of labor. In the book, Smith gave the example of a pin factory to illustrate the concept. Smith observed that an individual working on the production of a pin by himself could produce at most between 1 to 20 pins per day. By contrast, if the production of the pin were divided between 10 workers, each working on one particular step of the 18th step of the production, the result is 48,000 pins produced in a day. So how does principle of specialization applies to car making? To illustrate, we can take a look at how Henry Ford mass-produced the Model T. Prior to using the assembly line to build the Model T, most of the cars that were produced were handcrafted, which were time-consuming and extremely costly. Ford pioneered the assembly line in car manufacturing, which used standardized parts and employed labor that specialized in one part of the production process. The assembly line led to the production of the famous Ford Model T, which was remarkably affordable at the time and made car ownership accessible to everyone rather than just the selected few. Between 1910 and 1924, the price of a Ford Model T saw a 63% decrease, from $780 to $290. The car also saw enormous efficiency gains stemming from the principle of specialization. The Ford Model T was built to handle all types of terrains and conditions, including terrains on the countryside where there is no road and the car has to go through bumpy conditions. Similar production methods can be observed in China's EV sector, except that the specialization is primarily separated into two parts: software and AI-driven technologies and battery technologies. The production and R&D for EV battery for China is concentrated in two companies, CATL and BYD, which together holds over 50% of the global share of EV battery production. By specializing in battery production, these two companies have developed two major advantages. First, BYD and CATL benefits from the economies of scale, holding a tight grip over the entire battery supply chain, from the mining and the sourcing of raw materials like lithium and cobalt to refining, packaging, and the final assembly processes of the battery. This vertical integration, and by having control over the entire EV battery supply chain, reduces the cost of producing batteries, and it also makes it a lot more difficult for other companies and countries to build an EV without having to rely on these two companies' battery supply chain. Second, BYD and CATL specialization in battery production allows both companies to further innovate in R&D, pushing for batteries with lower charging time and longer range. To illustrate, in 2025, BYD shocked the entire world by claiming that its batteries can charge up to 400 kilometers of range in just about 5 minutes. What was perhaps more surprising was that only a few months later, CATL revealed that one of its latest battery can add up to 520 kilometers of range in also just about 5 minutes of charging. But regardless, together, CATL and BYD creates the perfect battery ecosystem that supplies the best performing and always improving EV batteries to car makers like Xiaomi, XPeng, NIO, and Huawei. And as a result, car makers like Xiaomi can specialize and focus on software and AI-driven technologies like driver's assistance and autonomous driving. These are the features that are increasingly becoming the differentiator between cars that are sold on the market and increasingly define what the future of the car industry looks like. The following clip is a perfect illustration of the autonomous driving capabilities that are widespread among EVs in China. What you see here is that the driver has left the car and that this car, which is Xiaomi's SU7 model, is going to be parking itself to the rooftop of a parking lot. As you can see, the car itself is intelligent enough to navigate various type of road conditions and various type of obstacles to park itself at the rooftop of this parking lot. And after a few adjustments, the car itself successfully parks into the parking lot without the need of any driver assistance. It is really this emphasis on technological innovation and software integration within the EV that is separating Chinese EVs from traditional automakers like Mercedes and BMWs. In this Bloomberg article written by Zhang and Wilkes, the author was able to interview Ryan Shu. Ryan is a car enthusiast as her family owns a Porsche 911, but even in her views, German cars have soured as Chinese consumers increasingly favor tech refinement over traditional selling points like horsepower and handling. She goes as far as to call the software system in Porsche Taycan EVs as terrible. And after experiencing some issues with their Porsche Taycan, the family sold the car and bought ET5 from the Chinese EV brand NIO. The ET5 cost about a third of the Mercedes EQE, but offer a more luxurious interior design and a smoother voice control. Shu noted that German cars can hardly match that level of technology seen in Chinese EVs, and that even traditional luxury automakers like Mercedes, BMW, and Audi can hardly be seen as luxury now. The following is a chart rating the global automakers on their digital strength. And as you can see, German automakers fall behind Chinese automakers like NIO, XPeng, and BYD. And the German automakers' inability to keep up with this digital transformation is also showing up on its sales numbers. For instance, Porsche recorded its worst third-quarter performance in China in a decade. And the German automakers' share as a percentage of the total EV market in China continues to decline. The rise of Chinese EVs alongside companies like Tesla demonstrates that the future of car making is increasingly shifted towards and defined by technology. The ability to innovate among these technologies, such as autonomous driving, requires deep expertise and specialization. Automakers that underinvest and ignore the importance of digital technologies will be left behind in the dust, while the challengers that continue to specialize and innovate will continue to race ahead.